Hey, I'm Tony. I'm here with Jesus and Lisette. We are Group 49 or LTJ Engineering, and our project was a mechatronic recycling system, or MRS for short. Just a little bit of background. The main purpose of our project was to separate and sort recyclable items like glass, plastic, and aluminum. Currently in recycling facilities, this is done by hand, or when you take your recyclable items to a facility, generally you have to sort it by hand. So this would solve that issue. And our solution, seen in the SolidWorks model, consists of a bucket that has a divider and is separated into three bins, which is that purple you see inside there. The top of the lid of the bucket will act as a hatch that will open and close and allow item to drop into the bucket once its respected bins underneath. And that's seen on the right side that has top. That hatch would slide open and slide closed. So for design specifications, for our structure, we wanted to use a 5-gallon bucket with 3 bin compartments. We wanted it to be able to detect glass, plastic, and aluminum. And for function, we wanted to sort one item at a time and not have it last longer than 10 seconds. And for cost, we wanted it to keep as low cost as possible and use as many parts from our kit. And this was our bill of materials for the MRS. As seen, we succeeded in keeping it low cost. The total project cost about $4, as everything else was included in the lab kit or provided by a team member.
For our functional requirements, we went with a budget-friendly method using the majority of our 106 lab kits. For example, we used the onboard accelerometer sensor and color sensor, 2 stepper motors, and the NRF, as well as additional parts from our team members. The accelerometer sensor acted as a cantilever beam to deflect when a glass bottle would be placed. The color sensor would distinguish between aluminum, since most aluminum cans have a silver bottom. And stepper motors, one would be rotating the bottom bin, the other one would be rotating a platform up on the top portion of the project, which will cause a bottle or a can to drop down once the platform is moved. This is our circuit schematic showing the connections from the NRF to each of the stepper motor drivers and the drop, which is set at 5 volts to work with the motors that were being used.
This is the primary circuit for our project, which was used to set up the 2 stepper motors by connecting it to the jock at 5 volts and then connecting the stepper motors to the ULN 2003 drivers. In2 to In4 was connected to the open digital pins, and then In1 was either connected to D2 or D5. In the code, we started by importing the correct libraries to use the stepper motors as well as the accelerometer and color sensors, and then we assigned the corresponding pins to either the motor for the bin or the motor for the top. And then we set up the code for the stepper motors, especially with steps per revolution that allowed the bin to move every 120 degrees to each of the 3 compartments, and for the top to move 180 degrees. And then we set up 2 functions, one called steps bin and one called steps top. The steps bin is so that we can make sure the bin only moves forward to the 3 compartments, and the steps top is to make sure that the top part can move forward and backward 180 degrees to open and close. And our main function was recycle, which every time got the new tilt value and color value with this if, elif, else statement that identified the material and proceeded with the following. So the first is identifying it as glass, which since that's bin 1, just opens and closes. And the second for elif is between 1,000 and 4,000 for the color value to identify it as plastic, which allows it to move forward once using step bin to the correct bin, and then opens and closes using steps top, and then moves forward 2 more times using steps bin to recalibrate to bin 1. And then the else statement is for aluminum, which does the same thing except moves forward twice to bin 3 for aluminum. Opens and closes with steps top, and then moves forward 1 more time to recalibrate to bin 1.
All right, here's our mechatronic recycling system. We have our microcontroller that is wired to 2 stepper motors. And the way this would work is you'd place a recyclable item over the top of the microcontroller using its color sensor to then detect what kind of item it is. This bucket would spin to its correct bin, depending on what item it is. And then this stepper motor would open and close the hatch and drop the item, or allow the item to drop inside.
The errors that came up when we were completing our project were the wiring of the stepper motors using the I2C pins, which caused issues when integrating the working test code into our project code. We attempted alternate pins based on MANA or PDF, but that did not resolve our errors. Moving forward, we will try adding the pins addresses to test if that resolves our errors. The stepper motors were also another part of it. They supply a low amount of torque, and that was resolved by adding bearings to the parts, which will be rotating, requiring less torque, and successfully moving our parts.
Future additions would be incorporating a OLED screen shown on the left to count the bottles that are in the bin, and a cleaning feature to make sure it allows for cleaning of any additional fluid or residual fluid of the bottles.